this video, we are going to understand graph data structure, and we will talk about some terminology and the representations of graph that we should discuss because the basic definitions in the terminology is associated with the graph, and it covers the adjacency list, and you can say adjacency matrix representations of the graph data structure, right? Let's continue. So I was talking about graph, right? So first of all, understand what is a graph, right? So a graph is a data structure, right? It's a data structure that contains, you can say, a set of what? Two things, right? First, there will be a vertices, V for vertices, and you can say this is nodes, or you can say and another is edge, right? So a graph is a pair, you can say, is a pair order, right? Or yeah, you can say ordered pair, right? So a graph is a ordered pair that is you can say it consists of a set of what or pair of two things. First, you can say vertices, that is you can say nodes, the vertices you can say, or nodes you can say, and this is a edge, right? So edge we can say, right? So when a graph is an ordered pair, right, means let's suppose if we have a graph G, right? So graph G, as you usually you have seen in your book, right, or in the class that when your teacher was teaching you in the engineering college, right? So you can see that we have what graph represents always by G, right? And where V is the vertices and E is the edge, right? It means a graph is a, you can say, an ordered pair where G represents a graph, where V represents you can say set of vertices, where or you can say node, and E is the edge of the two pairs that it connects with each other, right? So edges of the graph you can say, right? So give me one more second. Okay, so now I have changed my color of the pen, right? Pen color. So let's suppose if I have a V, right? If V contains how data 1 2 3 4 5, right? So if V contains like this, right? If edge contains what? Some value, right? Edge means some value is there, okay? So let's suppose our first node is connected with the fourth node, right? So how will I write the pair? So I said it a set, right? Edge is a, you can say edge is, we can say set is, edge is the set of you can say edges, right? Collection of pairs of vertices, right? So I will make a first connection 1 and 4, right? Similarly we can make another one, that is we can take 1 and 6, then we can, let's suppose represent like this, right? So it will become a little easy for us. So if we have 1 here, right, I want to connect with 1 to 4, okay? So let's suppose I will take 1, 4 is here, so that is why I have taken one pair 1 and 4. Another pair we can take 1 and 6. If I'll take one more here, right? So it can go in this way. So 6 is here, let's suppose. Next what we can take, we have 1 2 3. Let's suppose we'll connect 1, no, leave it 1, we'll connect and 6 and 5. So I'll take 5 here and I will connect with 5 and 6, right? Then we can connect 5 and 4. So we have to write also here. So I will write what? 5 and 4, right? 5 and 4 and 5. We should write 4 and 5. I have written like this. You can write like that, okay? 5 6, and then we can write what? Let's suppose we'll take 2 here. We are going to connect 2 with the 6, okay? So we'll take one more 2 6, okay? And let's suppose 3 we are not going to connect with any other, right? So we'll keep it simple like this. Now you can observe that I was saying graph, right? So graph contains graph contains what? A set of vertices, or you can say and collection of its pair, right? Like this. I think you understood this point that I was talking about. So this is called a graph. So in the simple word, we can say graph is an ordered pair where G represents graph, V represents vertices or nodes, E represent the edges, right? So we can say a graph is an ordered pair that comprises a set of vertices or nodes, you can say, and a collection of pair of vertices from V, right? Known as the edge of the graph, correct? Now, let's suppose how many types are there. Okay, so we'll see how many types are here. Okay, so if I will write like this, types of graph. Okay, how many types are here, right? So if you are already aware with this, right, types of graph, you can skip it. Otherwise, if you have time, you can observe. Okay, so types of graph are, let's suppose I will go with undirected, right? Undirected graph. Okay, then we can say directed graph, right? So basically a graph can be represented as undirected, directed, or there are some more advanced graphs like you may heard of DAG, right? So that is called directed or cyclic graph. Okay, and then we can say multi-graph. We'll talk about it, multi-graph. Okay, similarly we'll say graph. Okay, so or one more we can take a simple graph. We can also say simple graph, right? Let me think. And what are the graph we can have? Yeah, one more we can say weighted. Yeah, remember weighted graph, right? Weighted graph and unweighted graph. Remember, weight, there will be a weight on the edges, right? And that we can define that. Now think more. What are the things that can be here? So we have talked about undirected, directed, directed acyclic graph, multi-graph, simple graph. Then we can say I will write here. Okay, there can be a complete graph, right? Complete graph. Complete graph. Okay, this will become your 7th. Okay, then I will go with 8th. 7th, we have undirected graph, directed graph, directed acyclic graph, multi-graph, simple graph, weighted graph, unweighted graph. Then we can say complete graph. Then we can go with one more graph should be there. Connected graph. Remember, connected graph, right? So whenever you are talking to your interviewer, right, if there is a question, right, so we should understand which type of graph is there, right? So before understanding the theory, you can say most of the developers directly jumps on the questions, right? And when you jump on the question, definitely there will be a deadline for you and you cannot cross, right? Because that is your limit. You are not understanding the question, you are trying to attempt the question. Okay, so first of all, understand the type of the graph. So why we are going to understand? Because we have to make lead code question, right? We have to do that. We have to definitely we have to make it right. Let's suppose we are going to understand undirected graph. Okay, we'll start with the undirected graph. So what is undirected graph? So a graph that we do not have a direction. Let's suppose I'll write here 1, 2. So 1 is connected with 2, 2 is connected with 4, 4 is connected with, let's suppose, 6, and previously we have 3 is not connected with any other. Let's suppose we'll take 5. Okay, 5 nodes are there. Let me connect these things also. So as you can see here, there is no direction is there, right? Means nobody can say 1 is connected with 2 or 2 is connected with 1. We can say it is connected, but we cannot say direction that it will go here, this side or this side, like this side or this side. We cannot say. Direction means this is called direction, right? So is the node 1 and node 2 is connected with each other and having direction given or not. So if we want to understand the undirected graph, so we have to see the representation of the given graph, right? Otherwise there will be a statement where a statement will say a undirected graph. Then you have to understand, oh, this is having the graph, there is no direction. Means an undirected graph is a graph in which edges have no orientation. Means we have not given the direction or orientation, you can say. So let's suppose if we'll talk about, we have two edges, x and y we have given, right? Edge we have given x and y. It is identical to y and x. Means in this case, let's suppose we have edge 1 and 2 we are talking about, and another is 2 and 1 that we are talking about. So we have these two which is identical, right? And so they are not ordered pair. Ordered pair is what? Where we can say 1 after 2, right? We cannot go with 2 comma 1. That is not ordered. Okay, so there should be order. After that, once 1 is finished, so we will connect 1 with 3, right? Then we can connect 2 with 4. Then we can connect 3 with 4. Then we can connect 3 with 5, right? Then we can connect 4 comma 6, right? 4 comma 5, 5 and then 6, right? Then we can say 6 comma 4, but that is not we can say, right? So these order are ordered list, right? But when we are talking about unordered, they are not unordered, they are not ordered, right? So this type of order will not be seen in the undirected graph. So the maximum number of the edges which is possible in a undirected graph without a loop, we have to count, right? How we will count? N into n minus 1 by 2, right? Let's suppose how many edges are there here. So let's suppose we have given 6. I will write 6 into 5 by 2. I will do 3 into 5 is equal to 15, right? So total number of edges possible in a undirected graph without a loop will become n minus 1 into n by 2. You got my point? So you have to find out everything. Like I'm not talking about the ordered one. This is ordered one. Okay, this will not come into the undirected. When you define the undirected, you have to write also like this: 1 2 2 1 1 3 3 1, right? In this way, if you will count this, you will get 1 2 3 4 5 6 7. So you will say 7 into 2 is will come 15, right? So nearby it will come 15. Okay, so that is why this formula is we can say it will work, right? N into n minus 1 by 2, right? So number of edges we can find from there. So I think you understood the undirected graph. If you have any doubt, please ping me in the comment box. Let's go to the next. So in the next, what we have seen, we have already seen undirected. Let's go with the directed graph. Okay, what happened? Let's suppose we are going with the directed Okay, directed graph. Sorry, we'll go with the directed graph. So what is a directed graph? Let's suppose we have two nodes we have given, 4 and 5 we have given. So if a node having one direction like this, 4 to 5 or 5 to 4 like this, so this is called a directed graph, because we have given a direction. We have already given a direction. So first direction is saying here, another direction is saying here. Means a graph we have given, right, which is having a orientation, a direction, and that is why we can say it's a directed graph. So when the edge x comma y is not identical to edge y comma x, right? So here what will happen, right? It's not identical. So when we talk about 4 and 5 and 5 comma 4, so these both are not identical. Why not identical? Because we have given direction. These both are different. These both are not same. Okay, these are not identical. You got my point, because direction is coming from 4 to 5 and this is going 5 to 4. Just it is opposite. It's not identical. Okay, so this is called what? Directed graph. So when we are talking about directed acyclic graph, right? So what is acyclic graph? So there will be a, let me go to the next page. Okay, we are talking about DAG, right? So DAG is a directed acyclic graph. Okay, so a DAG will become when a directed graph will become having a cycle, right? Then there should not be a cycle. Then in that case it will become DAG, right? Means let's suppose how I talking about. Let's suppose I'll start with a 7. Okay, and rest of the things you can put into a box. Okay, so I'll put directly like this. I will create 5 here, then 4 here, then 3 here, then 2 here, then 6 here, and I can take in between line here and we'll say 1 here. Okay, now we'll do what? We will make a direction. Okay, so this 6 is going direction like this, right? These 3 going direction like this, these 3 going direction like this one direction here, and this coming direction here. Okay, this is going direction here and this is going direction here, and it is getting one direction from here, right? So if you observe this, right, all the orientations, right, you can see that there is no cycle. Why there is no cycle? Because if you see, it is going here, but it is not coming, this direction is not coming like this, right? It is stopping there, right? At 2 it is a stopping. If it is coming to 6 here, it will go here, right? But here direction should be like this, so it is not going there. Next, if you'll talk about, we are going here, right? And there is one direction is coming here. So if you'll go like this, right, this direction should be here, right? So due to this, it doesn't make a cycle. There is no cycle, right? When there is no cycle, right, it will become a DAG, or directed acyclic graph, right? That is called DAG. So you have to see the graph, right, and then you have to understand. Sometime problem will say graph is given, check is this a cyclic or not, right? So you have to find like this. There is a given direction is there or not, all the nodes are matching with each other or not. If there is one direction, right, number of the edge you have to see 6 and 7 having the direction or not. If the 7 doesn't have the direction, it means there is no cycle, right? So like that you have to think. Okay, let's talk about next what we have seen. We have observed a multigraph, right? Remember, multigraph. Okay, there is a multigraph. A multigraph is a undirected graph, right, which multiple edges, or you can say sometimes loops, are allowed. So multiple edges are like two or more edges that connects with the same vertices, right? And edge is an edge. A loop is a as an edge, directed or undirected, that connects with the vertex itself, right? Right, like this. There is a vertices, it connects with itself, right? There can be multiple you can say edges are there that connects with each other. Let's suppose like this. Okay, it is connected like this, it is connected like, and it is connected like this. Okay, so there can be more possibilities. There is some more elements are there that is connected with this. So if it is, there is a condition, right? So this is called multigraph, right? So when we are talking about simple graph have simple things. Let's suppose what is simple and what is multigraph. Okay, so if I'll keep very simple, 4 nodes I will take, right? And I will say let's connect all these nodes. Okay, these nodes I have connected now. Okay, let's suppose we will connect this also. Still this is a simple one, right? This is still, it is a simple graph. Why? Because a simple graph in which both multiple edges, right, and loops are disallowed. You cannot see that there is a loop, right? And so we can say it always opposes a multigraph, right? So what is multigraph? Okay, so let's suppose we have given 2 nodes like this, right? One is connected like this, another is connected like this. Okay, apart from that, let's suppose if we have another one, this is also connected with this, like this. Okay, and this node is also contained itself, means it is making loop, and it is say multi-edges, right? So this is your this is not a simple graph, right? This becomes your multi-graph. Okay, or this is called simple graph. So these are the basic concepts that we have to understand, right? So in a simple graph, if you observe that if there is n vertices, right, so every vertice's degree is at most n minus 1. N minus 1 degree is there, right? Okay, we'll talk more about this one, degrees and these things we'll talk. First let's understand the basic concept of the types of the graph. Now let's suppose one more was there, I think, the weighted graph. What is weighted graph? Weighted and unweightedly. Okay, unweighted. What is weighted and unweighted? Okay, so a weighted graph that associated with a weight, right, with each of its edges. Okay, let's suppose what I'm talking about, if we have given a graph, okay, if we have given a graph that contains what, some nodes. Let's suppose I have similarly same one that we have talked about. Let's suppose this is 4 and this is your 5. Okay, so this contains 3, but when it is going back to the same one, right, it contains only 1. We can say let me clean this one, I should clean. Okay, so it is containing what, the weight is here 3, but weight is here is 1, right? So a weighted graph, you can see here, right, have a weight with every edge in the graph, right? Means it is associated with a value that is called weight. One is 3, one is 1, right? Each edge having a weight, right? So we can also use words cost, you can say, or length instead of the weight. Either you can say weight, length, or cost. Anything will work. Okay, so an unweighted graph, right, this is a weighted graph and unweighted graph. So a unweighted graph is a weighted graph, okay, with all the edges as 1. Okay, unless we specify something else. So all the graphs we will say is unweighted by default. If we will not define any weight, let's suppose here if we have 4, and if we have 5, if we are connecting these graphs, we are not giving weight, right? So by default it will become unweighted graph. Now let's talk about let's talk about what there was a complete graph also, right? What is complete graph? Okay, what is complete graph? So a complete graph, let's suppose we have a very good symbol was there, I forget actually. You can make a hexadiagonal, right? If you able to make, I'm just trying, don't laugh on me. I'm also okay, let me clean again. I will try, don't worry, I will retry. Okay, so let's suppose I have one here, another here, another node here. I can take one node here, one node here, then I can take one node here, one node here, I guess. Yeah, now we'll connect with each other. Let me change the color. I will let this one. Okay, so I'm connecting with here, here, this will connect to here, 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 here. Okay, now all these nodes are connected. Still we will connect each other like this. You got my point? We'll connect all the nodes. Okay, even I can connect this with this, this with this. We have to connect all the nodes with each other. Try to connect all the nodes. This will go here. So we can say each of the nodes we can connect each other, right? So when every two vertices are adjacent, right, all the edges that could exist are present. Whatever the you will think this is there or not, right? So all the edges could exist as a it is already present, right? Then in this case we can say this is a complete graph, right? When two, or you can say every two vertices are adjacent, right? Then all the edges that could exist are present, right? And then we can say this is our complete graph, right? Let's suppose a connected graph. What is connected graph? The name says, right, connected. Who is connected and who is not connected, right? Like that. I don't know which number is this, right? But you should understand. Let's suppose what is connected graph. So when I will write some nodes, right? Let's suppose I will write some random nodes are there. Okay, let's suppose 1 2 3 4 5 6, and then I will connect each others like this. And like this. Okay, so each of the nodes are, you can say, connected, right? So when a connected graph has a path between every pair of the vertices, right? Okay, I try to connect everyone, but if there is not connected, let me know. So if a graph, right, if a connected graph has a path between every pair of the vertices, in other words, there are no unreachable vertices. A disconnected graph is a graph that is not connected, but this is a connected graph. Okay, so I have tried to make it very simple, clear, but if you have you have doubt, please ping me in the comment box. Let's understand the most common term used in the graph, right? So there should be an edge, right? What is edge? Edge is between two vertices we will connect, then it will become edge, right? What is adjacent? When two vertices are called adjacent, right? You know, adjacent, we'll talk these things, right? So what is edge? Edge is the edge connects two vertices, right? Basic unit of graph, you can say, to construct a graph, right? when we talk about the two vertices, right, two vertices are called adjacent if their endpoints are the same edge, right? Ongoing edges, incoming edges, we can say what is the degree? Yeah, then we can say degree. What is degree? So degree of a vertices in a graph is the total number of edges, right? Okay, then think about in directed graph, out degree of vertices is the total number of outgoing edges. So let's suppose also edges, right? This you will heard about incoming edges, outgoing edges, right? Similarly you will see in the in degree, out degree, right? So these things you have to understand. So the S is a you can say a basic unit, right, to connect the two vertices together, right? So when we construct a graph, right, so it is a basic unit. So when we construct a graph, we require to add more edges, right? And then you can say each edge has two vertices, right? So vertices 1, vertices 2, v1, v2, you can say node also, right? So when we connect these two, right, then it become edges, right? Similarly, when two vertices are connected, here v1 and v2 is connected, so this is called adjacent, means v1, v2. So this is called adjacent. Okay, so if they are endpoints of the same edge, because they are the same edge, so we can say this is adjacent, right? Adjacent is, you can say, neighbor also, right? Now think about outgoing edges, ingoing edges. Here if we will write like this, right? So this is outgoing edges and this is called ingoing. For this edge, v2 have incoming, right, and v1 have outgoing, right? So you have to think about, you have to see the direction and then you have to decide. The vertices are always in the directed graph, right? What is the degree of vertices in a graph? So degree of vertices in the graph is the total number of edges that we see in the graph, right? And in a directed graph, the out degree of the vertices is the total number of outgoing edges, right? And if we talk about the in degree, the total number of incoming edges. How? If there is multiple nodes are there, right? So if I will write like this, okay, and it is going to 1 here, okay. So if you talk about the in degree, right, in degree, so here it is what, 1, 2, 3, so it will become 3 here, plus 3 you can take, and here minus 1, right? So total if you will balance, 3 minus 1 is 2. Those things we will discuss more. What you can say, what is out degree, what is in degree, right? You understand? Okay, now think one more thing. What is cyclic, right? When it is cyclic, right? So let's suppose there is 3 nodes is there, right? So it is connected like this. So if a node, if there is vertices, if the vertices are connected with each other, or you can say a cycle, right? People are also saying cycle. A cycle is a path that start and ends at the same vertices. You can choose any of the vertices and you can say this is cyclic or not. So in the simple path, the path having the distinct vertices is called simple path. So in the simple path, right, the distinct vertices we have, right? And on a graph we have a strongly connected graph we have. There is a weakly connected graph is also there. There is a bridge is there. This connected component is there. So everything you have to understand one by one, okay? And most of the things in this series I will talk about everything.